Welcome to GM Institute Davangere. I'm Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 5. That is a single phase controlled full wave rectifier with R load. So aim to turn on single phase full wave rectifier using single phase converter using firing circuit. So contents: aim of the experiment, theory, apparatus required, circuit diagram, procedure, calculations, results and graph. Theory: a single phase controlled full wave rectifier with R load uses SCR to convert single phase AC supply into controlled DC output. The circuit consists of either 2 SCR with a center tap transformer or 4 SCR connected in bridge configurations. Supplying a purely resistive load, when a AC voltage is applied, the SCRs are triggered at a firing angle alpha using a firing circuit. In the positive half cycle, one pair of the SCR conducts and supplies a current to the load, and in the negative half cycle, the other pairs of SCRs conducts, maintaining the same directions of current through the load. Apparatus required, that is single phase converter using firing circuit is required. Single phase full wave and half wave controlled power unit circuit module is required. CRO and connecting wires. So this is actual circuit diagrams. We are providing the AC supply with the center tapping transformers, and these are the 4 thyristor bridge configurations R and L loads we have. So we have to analyze this will be given T1, T2 and T3 and T4. The gate pulse will be given by the firing circuits. So procedure: switch on the main supply to the firing circuit, observe all the test points by varying the firing angle and triggering outputs on and off key, observe the trigger outputs and phase sequence, make sure that all the trigger outputs are proper before connecting the power to the power circuit to the triggering output pulse with the width varies as we vary the firing angle, and make the connection as per the given circuits. Connect the R load between the load points, connect the firing pulses from the firing circuit to the respective SCR in the power circuits. So switch on the MCB, switch on the trigger outputs and note down the output voltage, current and also the waveforms across the load and the device. So draw the waveforms across the load and device for the different firing angle alpha. Repeat the same for the different input voltage up to maximum voltage as provided in the isolation transformers. So repeat the same for RL load with and without freewheeling diodes and note on the waveforms. So this is the firing angle alpha. For 0 we got 25 volts, for 30 degree it is 24, for 60 21, for 90 12, for 120 it is 3, for 15 degree it is 0 voltage, for 180 it is 0. So this is actually the waveform. This is the input waveforms, that is sinusoidal waveform. We have given the from the center tap transformers. So and this is for the firing angle alpha, where you can see there is a thyristor has been fired with respect to T1 and T2 in the positive half cycle and T3 T4 in the another half cycle. So this from alpha to 0 to alpha is the firing angle alpha. So this is actually the output waveform. This is the voltage, load voltage across the load points, that is a resistive load and as well as the inductive load. This is the load current across the resistive and inductive load. T1, T2 are the thyristor during the conductions, T3, T4 are the thyristor during the conduction of the another half cycle. Results: single phase controlled full wave rectifier with R load with a freewheeling diodes are verified. So let us see how this can be conducted in the real time, the experimental. Let us go with the experiment conductions in the real time. Hi, hello everyone. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the single phase full wave rectifier using R and RL loads. So for that we require the apparatus. So this is a single phase converter of power circuits. This is a single phase converter power circuits. We have the isolation transformers, we have the firing circuits, we have the resistive load and we have the inductive loads, and this is the CR. So these are the apparatus required. So now we have to make the connection as per the given circuit diagrams. So once the connection is done, we need to give the DC voltage, AC voltage of 30 volts. Then we have to vary the firing circuits from the 0 to 0 degree, 30 degree, 60 degree, 90 degree and as well as the till 180 degree for the half cycle. Then we need to check output voltage across the load. So we have connected the output voltage across the load, that is we have connected the CRO. Let us see across the CRO once we vary the firing angle alpha. So when you vary the alpha, the voltage is also getting varied. So I set it for the 30 voltage now. So we are going to find out the alpha, that is 0, 24 and 30 and 27, for 60 degree 23, 90, 15, 20, 120 it is 9, for 150 it is 0, 180 it is 0. Now let us see what is the waveforms across the CRO, that is across the load. We need to check what is the waveform across the CRO. So this is how we will get the waveforms across the CR, that is across the resistive loads and inductive loads. We need to plot the graph across the alpha versus the volts. Thank you.